Hi everyone, welcome back to my channel. I hope you are doing great. In the last video, we are exploring the technical aspects of LangChain, including connecting to the LLMs, creating the prompts, chains, and out parsers. If you missed it, make sure to check it out. We are linked in the description below. Now, in today's video, we are going to be even more exciting because we are dive into the practical components of retrieval-augmented generation of RAG. We'll cover how to use the custom data loader in the LangChain, the different RAG components like splitter, embeddings, vector search, retrievers, and top case selection, and hands-on example to show how these components works together. By the end of this video, you will have the solid understanding of how RAG works and how you can implement it in your project using the LangChain. So without wasting any time, let's get started. What excites you the most about the RAG components? Let me know in the comments below. So first is data loader using the LangChain. Let's start with how to load the data into the LangChain using the custom data loader. The data loader are essential because they allows you to ingest the document or datasets that we want to our AI model to be work with. LangChain provides the tools like LangChain community for loading the data efficiently. The code loads the text files into the LangChain so we can process it further using the RAG techniques. Let's see how it be done using the code example. Now we'll use the LangChain to load the different types of files like text, CSV, HTML, PDF, and even the data from the Wikipedia, and ask the question using the OpenAI ChatGPT model. Let's break it down this in line by line, and I will explain everything from the simple way. So first we will import the environment variables and packages. In this part, for the setting up an OpenAI API key securely, we are using .env file for the store the API key too, so we don't hard code it in this script. And the load .env loads the environment variable. Then we access the key using the OpenAI key, os.environment OpenAI key. Next, we'll initialize the chat model. So for that, we will import the OpenAI model from the LangChain OpenAI. We are initializing the chat model, that is chat OpenAI. In the model will be GPTI 3.5 Turbo 0125. Next, we'll load the first we'll load the .txt file, means text file. So for that, from in the LangChain, there is a LangChain community. In that LangChain community, we are using the document loader. In this document loader, we have the different function here: text loader, PDF loader, CSV loader, and Wikipedia, and the HTML loaders. Everything will be available. We'll see one by one how it can be done. So here, now we are using the text loader. Now we are loading the txt file using the text loader. This will read the plain text and plain text files and make it ready to use for the question and answers in the any NLP task. So here I already placed the text file here. So it get the data from the data folder and be a text file. So we need to pass the file path, and it will load the text value, and it will assign to loader. So it will, when we call the loader.load, it will load the text data. Okay. So here the loader will load the data to the loader data. So to see the loader data, print load data. So this is the data we are fetches from the be good text. So same thing. Now let's move on to the CSV loader. So first, that from the data document loader, we'll have to import CSV loader. Here everything will be the same, but we'll copy this. here instead of text loader we have to call CSV loader and the CSV file. CSV. So here what will happen now? We'll just comment this now. Here I will call the CSV loader, so it will fetch. We need to pass the CSV file path. Then it will when we call the loader.load, it will load all the data in the loader data. Since CSV, this can be useful when you are working with the data in the rows and columns, like an Excel sheet on that. So let's check how it will work. So this is the data. So same thing. I think data was be huge. We'll reopen one second. So this is how the CSV data will be loaded. Next, we'll use the unstructured HTML loader. So for that, we'll load the unstructured HTML loader. The same functionality will be there. So now here in using the unstructured HTML loader, we'll pass the HTML file path. It will load, and when they call the load.loader, it will be data will be loaded in the loader data. Then same thing will be can be done using the PyPDF. Means PDF, we can read the data from the PDF. So PDF. So here so using the PyPDF loader, we have to pass the file name path, and we are after calling the load data splitter, it will load the data from the here. Here one point is here we are not calling the directly load. Here we are calling the instead of load, we are calling load and splinter, because in the PDF will be the huge data. So we are splitting the content into pages or chunks for the better process. Next we'll see how to use the Wikipedia data. So for that we have to load the Wikipedia loader. So in that we have to pass the query name and loader maximum doc. Here query name is whatever the content you want to search in the Wikipedia, those data has to be passed, and the load maximum doc is equal to 1 means here if you give 5 means 5 related pages will be selected. If you select 1 means if you are 5 related, one web page will be selected. So let's see, we'll ask a question related to UFK. We'll search JFK, then print the lower data here. Okay. So this is the data we fetched from the Wikipedia. So now we will use this data to to pass this to the ChatGPT to get the some response. So let's check out that. Yeah, as we know, we from the LangChain core we are importing the prompt chat prompt template. So in this in that we are asking sending the human question that answer this question. We are passing the question template, and here is the same extra context for that. So for the context we are passing the load data that we'll do in here. Wait, so now here in the formatting message, name will pass it as a JFK, and the question will be where was the JFK. For the context we will pass the load data. So let's invoke that message. Also first we'll print the content. Okay, now we'll get the output. So now we'll be acting actually values in the template. Now we are filling the actual values in the template. We are asking the question where was the JFK was born, and giving the Wikipedia content to context, and they will calling it the invoke to get the model response. So let's check. I'll comment this. So in the final, we print the answer from the model. We got the answer that JSK, the United States privilege, was located in the Flushing, then the New York City. Okay, so we got the answer. So now you know that how it load the data from the different file type and ask us a smart question using the LangChain and OpenAI. And if you found this helpful, let me know on this comments below. And also think of it like if we are now we having the data with the huge data, means huge data. So in the PDF we have millions of pages, means we can't send those millions of pages to the LLM for the context purpose. So that's in that case we are using the RAG. In the RAG we are having the splitting, embedding, vector storage, retriever and retriever methods. So those are now we'll get to know what is the importance of the now we know to what is the importance of the using the RAG operations. So let's see how it will work in the coming videos. What is RAG and why do we need it? Well, when we are working in large documents, something the text is too big to fit into the context window of the LLM. This is the where the Retrieval-Augmented Generation comes handy in this. So steps for the RAG: splitting the documents into smaller chunks using the splitter. Then transform these chunks into the embeddings, nothing but a numerical representation. Then stores the embedding in a vector database for the faster retrieval. When the query is made, then the retriever the most relevant embeddings. Then send those embeddings to the LLM for generating an accurate response. RAG ensures that large datasets are processed efficiently while maintaining the context and relevance. First is text splitter. Splitter divides into loaded documents into the smaller chunks for the text for easier processing. Let's look at two types of splitter. First is character splitter, another is a recursive character splitter. Character splitter splits the text based on the specific character and measures the chunk's length and by the number of characters. Well, the recursive character splitter tries to split the text into the paragraph first, then the sentences, and the finally words. Maintain the semantic integrity by the keep relating pieces of a text together. Let's see the code example of the both type of the splitter. Now we'll load the text file using the LangChain and split the text into the smaller parts, that is nothing but the chunkings. Then we'll use the chunkings to load to the LLM module. So first we'll as we are doing from the previous videos, first we are loading the OpenAI API key from the .env file. This keeps the key private and safety. Next we'll load the LLM module, that is chat OpenAI model. Then we are importing the LangChain community and document loader. As we discussed earlier, using the text loader we can read the text file, Using the text loader, we'll pass the text file path. Then using the loader.load, we will get the data from the text file. To see the data, so this is the data which we are getting. Next, using the LangChain splitter, text splitter, using the LangChain, using the LangChain text splitter, we'll get the character text splitter. So here we are using the text splitter. In this character text splitter, to break the text into similar pieces or chunks. Why? Because the LLM like GPT works better when there is shorter inputs. As we know, with in the LLMs we have the context window problem. So that to overcome that, we are using the Jenkins text data. Here the separator /nn splits the text where there is a double line breaker. So chunk size is 1000, means the thing, but chunk, each chunk has the maximum of 1000 character. Then chunk overlap is 200, nothing but each chunks overlap to the next one by the 200 characters. Next, the length function is length. This means we are using the normal character count to measure the length. Then we'll load the data to the text splitter. Here this creates the chunks from the first page of the loaded text. It returns the list of small documents that can be sent to the model easily. So to print the chunk information, to get to know what is the chunk information, see there are two chunks in this. So same the length of text you can get it. You can also know the length of the text, so that then will be good. Okay. Next, adding the metadata to the chunks. Here we are adding the metadata to each chunks. This helps to when you are tracking with which chunk came from where, and or add any tags, or we are giving each of the chunks to a number, then it will get handy. So to view that, here we will get the chunks along with the metadata. So when we execute, so this is the chunk. Be good, metadata will be chunks number 0. So this is the chunk we have. and that's how you load the text files and split into smaller parts and add the metadata in the LangChain. This is a basics but powerful step to building the RAG up pipeline or a chatbot system. Let me know in the comments below if you want to know if you want me to show any next steps or chunkings in the embeddings that you want to use in the chatbots. Next is embeddings. After splitting the text, we are converting the chunks of text into the numerical vectors that can be stored in a vector database for the faster retrieval. Why we are using the embeddings? Vector database works faster with the numbers rather than the text. Embedding captures the semantic meaning, making the search more accurate. Let's see the embeddings in the code example, how it works. We have split the text into the chunks. Let's move on to the next step, that is we'll cover those chunks into the embedding using the OpenAI model. Embeddings are just a number. They helps the AI to understand the meaning and context. So as we did, first we'll load the environment variables and the OpenAI API key. Next we'll import the LangChain OpenAI. LangChain OpenAI. In that we're importing the OpenAI embeddings. From the using this OpenAI embedding, we are creating the embeddings for the text. So for the sample purpose, so here is we created a small list of sentences. In the real use, would be the chunks of creating earlier as for the text file. So next, now creating the embeddings. Here now we pass our list of embeddings document method. This will return the list of vectors, one of the each sentences. Here we'll convert the text into the embeddings. This tells us how the embeddings were created. In this case, we will get the 5 ones for each sentence, I think. Let's see by practical. So we got the 5. We'll get the 5 ones for one of the each sentences. So next we'll check the embedding size. So to get the embedding size, so this shows the number of values in one embedding. Usually OpenAI returns 1536 number for each sentences. Next, printing sample from the embeddings to know how the embeddings will look. So here is we printed the first 5 values for the first embeddings. This helps to understand how those vectors looks. Just a floating point numbers it is. And finally embedding a query. So this will finally will embed the user query. This is useful when someone is asking a question. We convert this into the vector and compare it with the text vector to find the most relevant parts. And that's how you generate the embedding using the OpenAI in the LangChain. We have turned the text into numbers, and now we can use them to find the answers in the searching documents or feeding into the vector database. Vector search. Vector search are a specialized database that stores the embeddings and allows a similarity search based on the query. Let's see how it has been done, will be done in the code. So now we'll see how the embeddings will be stored in the vector database. Here has a we are using now here we are using the ChromaDB as a vector database. We load the text files and we'll load the text file, split it and embed it and save it in the vector store. Then we will ask the question of the retriever to most relevant answer. Let's see one by one. First we'll load the data from the text loader. I think we are loading the .txt file. This could be any speech, articles or any notes. Next we will split the data into the chunks. So for that, this brings the documents into the 1000 character chunks with no overlaps. Why chunks? Because as we said that because of the larger documents are the too big for the models to handle these at once, it will be difficult for that. Next, vector DB. Initializing vector DB. Now here we using ChromaDB as a vector DB. So here each chunks is turned into the vector using the OpenAI embeddings. Then we store this in the Chroma, which is lightweight and vector database. So our embeddings will be stored in vector DB. We can ask the question to get the similarity. So we'll ask the question. We'll pass that question to get the similarity search. We'll go through similarity search. Here when we type a natural language question, then LangChain turns into the vector and compared with the stored chunks, and then we'll get the similarity search content on that. So to see the printing, the chunk, similarity chunk. This gives us the chunks of the text that most similar to the question. This is the retriever part of the RAG. You can now pass this to model to the GPT or generative. So let's execute and check. So this is the chunk where the questions asked question having the answer. Just a second to understand. Instead of 1000 we'll make 50. Then you will get a bit understandable. So this is the chunk having the answer. And that's it. You just build some simple RAG system using the LangChain. You ask the real question and pulled out the best match text using the vector similarity. Retrievers. Retrievers fetches the relevant documents or information based on the unstructured query. They can use the vector stores as their backbone, but offers the additional flexibility. Let's see the code example on this. Now we'll explain how this code loader text the file and breaks into the chunks and convert it into embeddings and stored in the vector database, and the answer question from it using the similarity search. Let's go by step. First we'll import the API key. So as discussed earlier, we are using the .env files to store the OpenAI key. So you load .env environment variable from the .env file, and then it will be fetched from the API key using the os.environment OpenAI API key. So next we'll import the lang OpenAI model. In this, as we importing from the last video, we are importing here the LangChain OpenAI wrappers, where we are using the chat. We are using GPT 3.5 turbo model. Next, we'll import some packages. Here we used read the documents, split the text into the chunks, and create the embeddings, and then stored into the Chroma vector DB. So for that, these imports will be helpful. These packages will be helpful. Next, first we'll read the data from the text file. So we'll load the documents. Here we are loading the text file. In this case, state of the union text. Now we'll split this into chunks. Then we will break the large document into smaller part chunks of 100 character each. There is no overlap between the chunks. Next, we will convert this into embeddings. Here each chunk is converted into embedding using OpenAI model. These embeddings are stored in the Chroma vector DB. This will help us to search for the similarity text where we ask the question. Now let's ask the question. So now we are asking a question. The system will convert this question into embeddings and compare it to the stored text chunks and returns the most relevant answer. So let's execute and check. Before that, we'll print. So this is the chunk having the relevant answer. So we saw the vector stored in the Chroma DB. Now we can do the same thing from in the faces DB instead of the Chroma DB. Let's see how it can be. First we'll import faces. Next, everything will be the same. Instead of vector DB, we are calling here Chroma DB, we are calling faces. That's it. Rest all everything will be the same. So as how we see different loaders, means PDF loader, PyPDF, CSV loader, text loader, same thing here also. Chroma DB and devices will be only the calling the function, it will be the difference, but methods will be the same. Since we are using the same orchestration framework, so the calling methods will be the same, but so this is how simple RAG pipeline works using the LangChain. You OpenAI embeddings and vector stores like a Chroma or faces. You can use this same process for using your own PDF articles or any large text file. Top case selection. Top case selection determines how many embeddings should be retrieved for the answering a query. For example, if the k is equal to 1, retrieves only the one most relevant chunks, or k is equal to 5, retrieves the top 5 chunks based on the relevance. These parameters helps to balance precision and context when generating the response. Let's see the code example of that. So as discussed earlier, everything will be same for the k value, but the one changes is in the retriever function. We'll mention the search keywords is equal to k is equal to 1, where the if any chunks having the similarity of only 1, then only those chunk will be only one chunk will be retrieved. If you mention as a 2, only 2 chunks will be retrieved, so that it will be, if you mention it will be useful for the k values. So we'll tell that retriever to return only the top one matches, and top one matches something you only wanted to most relevant results instead of the list. So that's it. Now you know how to load the document, split into chunks, and convert into embeddings, and store the vector DB like Chroma or Physis, and asking the question and get the answer. This is the base of any RAG, Retrieval-Augmented Generation system. You can apply to the PDF, web page, or any loader. Let's summarize what we have learned today. Custom data loader in the LangChain helps to insert the document efficiently. Text splitter divides the large documents into manageable chunks. Embeddings transfer the text into numerical vector for fast storage and retrieval. Vector stores enables the similarity search using the embeddings, and the retrievers fetch the relevant information based on the queries and can integrate with the vector stores. Then top case selection fine-tune how many chunks are retrieved for answering a query. With these tools, you can now implement the RAG techniques in your own project. Thank you so much for watching it. If you found this video helpful, please give you thumbs up. It really motivates me to create more content for you. Don't forget to subscribe for my channel and hit the bell icon so that you don't miss any episodes in this exciting GenAI series. Now here is my question for you. Which components of a RAG, that is splitter, embeddings, or retriever, do you find the most interesting? Let me know in the comments below. In our next video, we'll see some another LangChain components and like memories and LCR. After the completion of all the topics of the LangChain, then we will build the level 1, level 2, and level 3 application so that you'll understand how industry will work. Until then, keep exploring, stay updated with all the things of here. See you in the next video. Bye bye.